Hi everybody, these are our first section of notes for Unit 11. So what we would like you to do is make sure that you have a piece of paper out so you can jot down the most important information and of course all the examples. You'll notice up top here, I've even circled it for you, there's actually a little symbol of a pencil. So basically, to make it a little easier for you, wherever you see the pencil marking, that's what we want to make sure that you get down in your notes. So first and foremost, whenever you're taking notes, make sure you have the title of your notes. So the first thing we would like you to write down is right up top here. You should be writing down Unit 11, notes number 1, solving quadratic equations using factoring. And if you remember from our last couple of units, guys, a quadratic equation, a quadratic means that you have a variable. In our case, we're just going to use x to make it simple, but you're going to have at least one variable that's raised to the second power. But before we start talking about how we're going to use factoring to solve these types of equations, there's just one thing I want you to consider. Now, first and foremost, notice there's no little pencil there, so therefore you don't have to actually write this down. I just want you to kind of think about this. So the first statement I've got here says that 2 times 0 equals 0. And hopefully everybody's looking at that saying, well, yeah, duh, okay. I know that anytime I have a number and I multiply it by 0, it gives me 0, okay. Well, now notice how I changed it up for this second one. So now I've got 2 times some letter, I don't know what it stands for, but it still equals 0. Well, again, if two things are multiplied and their product, their answer is equal to 0, well, then the only possible thing A could be would be 0. Now for the last thing over here, now I don't know one number. I just have 2 letters, A and B, 2 variables. They could represent anything. But what I do know is that if I multiply them, I get 0. Well, if we think about that, then I guess this guy could be the 0. Or I guess this guy could be the 0. It could be either or, we don't know. And that's what leads us to this most important thing right here for this section is something called the zero product property. Now again, notice the little pencil symbol, so please make sure that you write this down in your notes. The zero product property tells us that if AB equals 0, now just to be clear, that means A times B. You may see it with a dot, maybe it's A and then B in parentheses, kind of like how we see it up here. Maybe this A represents something in a set of parentheses and this B represents something in the set of parentheses. But either way, we're saying that we're multiplying 2 pieces and we know it equals 0. Well, then all we can say from there is that either the first piece, the A was 0, or the B must have been 0. That's the only way you can get a product of 0 is for one of your pieces, one of your factors to be equal to 0. Now, as a quick note, there's no other product property other than the zero product property. So this is going to be super important with all of the equations we're going to solve. In fact, if you take a look down at the first 2 examples, you'll see that they're both set equal to 0, because that way we can apply this zero product property. If these had been 1s or 2s or -8s, we would not be able to do this property because there is no A product property. There's only 0. So if you take a look at number 1, we're saying that we've got 2 things being multiplied and they equal 0. So kind of picture this as like the A and this is like the B. I've got 2 things that are multiplied to be 0. So what that tells me is either this entire thing here, x plus 3, that must equal 0, or this entire thing here, x minus 8, that must equal 0. So we're just going to simply solve both of those equations. So x plus 3, we'll have to subtract 3 from both sides, and that will give us -3. Over here, we'll add 8 to both sides. Remember to use inverse operations. all that algebra we've been doing all year, and that gives us our two possible values. So if I plugged in -3 in for this chunk, -3 plus 3 would be 0, and now of course that makes the answer 0. Or let's say our x value was 8. We plug it into this piece, 8 minus 8 is 0. Again, I don't care what this is going to be. I know that when I multiply, it's going to give me 0. So the thing with quadratic equations that we don't see with our regular linear equations is that you're always going to have two answers. So our answers for this is x equals -3, x equals 8. And you can just box or circle those answers, or if you want to be real math nasty, you'll go ahead and you'll put the two answers in braces. So that tells us that is our solution set. The possible solutions are in -3 and in 8. Okay? Moving on to number 2, it's pretty much set up that same exact way. We've got the 2x on the outside, and that whole thing is being multiplied to x plus 5. Again, treating it sort of like up here. All this is saying is I've got this quantity that's A being multiplied to this quantity that's B, and guess what? It equals 0. Okay, so I just keep kind of pulling back to that zero product property so you really understand that all we're talking about here is having two things being multiplied, and therefore if they're equaling 0, then either one of the terms is 0 or the other one is 0. The only extra thing we're throwing in is that now we've got to solve those two. So we talked about something being multiplied to equal 0 up top here. In this case, it was an A, and we said, well, yeah, of course it's 0. But again, guys, you can just use your algebra solving that we've been using all year. 2 times x, well, to get rid of that, I'll divide by 2, and that will give me x equals 0, so that's one of my answers. And then over here, we'll subtract 5 from both sides, and that will give us -5. So that will be our other answer. And if you'd like, you can put these two answers in braces. Now you should know that if you are going to put them in braces, okay, you put the lesser one first and the bigger one second, okay? But again, the braces are not a necessity. It's just to show you that that's sometimes how you may see the answers to equations that have more than one solution. Now, some things you might be asking yourself, this apparently is you, okay? You might be saying, well, yeah, but what if the equation isn't already factored like that? Or maybe, what if the equation's not already set equal to 0? What am I gonna have to do then? Well, hold on to your hats, because here we go. All right, you'll notice in our second page here, guys, I've got the little pencil symbol up here. So please make sure you write down these steps, okay? These will be really good steps for you to follow while you're doing the homework and while you take the quiz that involves material like this. So steps to solving quadratic equations using factoring. So the first thing you want to do is to make sure that your equation is set equal to 0. So set your equation equal to 0. That's because of that zero product property. There's no way we're going to be able to do anything else unless I have 0 on one side and everything else on the other. And I just want to remind you again, I say use algebra to move all the terms to one side of the equation, but you know what I'm talking about. I'm talking about the inverse operations, the opposites. And then definitely make sure they're arranged in the proper form. We call that standard form when we have our x squared term first, then our x term, and then our constant. That'll just make it a lot easier to factor. Once we have it set up with everything on the one side and 0 on the other, we're going to factor it, okay? Now, it could be that you just need to factor out a GCF. Could be that you're going back to the beginning of the factoring section where we did double grouping. Maybe you're going to do that X method they talked about. Maybe it'll be difference of perfect squares, but you will have to use some form of factoring so we can get those pieces that are being multiplied. And then lastly, you're going to do exactly what we just did on the first page that I showed you. And we're going to set each factor equal to 0, solve, circle or box your answers, or if you want to be real fancy, you'll go ahead and put them in the braces. So at this point, guys, okay, a good idea would be to pause the video to make sure you have all of these written down. I'm going to move on to the examples. I will again assume that you've paused the video so you have these all down in your notes. And if not, pause again. All right, and let's go ahead and start with some examples. Again, you see the pencil because, of course, all examples, super important. So our first example here, okay, if we think about our steps, we want to make sure that it's already set equal to 0, which it is, so check, we've got that 0. Now we want to factor. Well, the first thing I kind of notice here is that I only have 2 terms. So there's not that whole x and a times c and b. I only have 2 terms. So when you only have 2 terms, what you really don't want to think about is, let's look for a GCF. Let me look at each of these terms and see, do they have anything in common? Notice that they both have an x. So what I'm going to do is I'm going to divide out that x and put it out in front. And then inside the parentheses, just go our quotient. So x squared divided by x will give us an x. 7x divided by x will give us a 7. And we've got that plus sign in the middle. So now we're still set equal to 0, good. And now we actually have things being multiplied, so we can now apply that 0 product property. So this tells us that this left piece, that's the x, well, either that guy equals 0, or this right piece, which is an entire x plus 7, well, that might be the piece that gave us the 0. Now, the good news for us is that this first guy here, we don't even need to do any work. He's already by himself. Score. One of our answers is 0. Over here, though, we will have to do our algebra. We'll have to do our inverse operations to move that 7 to the other side, and that will give us -7. If you're writing it in braces, the -7 would go first, and then the 0, because -7 is less than 0. Now number 4, notice that it also only has 2 terms. But in this case, there is no GCF. Well, the other thing to think about when you only have 2 terms is, well, maybe it's difference of perfect squares. So notice that 4 is a perfect square, and so is 9. So this is what we call difference. I'm going to use abbreviation of perfect squares. This was the last section we had in our factoring unit on Edgenuity. And what we had done for the factoring unit, for that section of the factoring unit, is we said, well, we know that we will end up having 2 sets of parentheses. But what we have to do is actually square root the terms to know exactly what's going to go in there. So we square root the first piece. So when we have a 4x squared, well, the square root of 4 is a 2, and the square root of x squared is an x. Remember what that square root is telling you. It's telling us that if we take this 2x and we multiply it by himself, I will get 4x squared, and that is correct. 2 times 2 is 4, x times x, x squared. Then we'll go ahead and take the second piece, the 9, ignore the minus sign for a second, and if I square root the 9, that'll give me a 3. So that will be the second term in each of my parentheses. And then because it is difference of perfect squares, and I know that I have a -9 here, that means I'm going to need 1 plus, 1 minus. So when we have difference of perfect squares, they're going to be the exact same binomials, except one will be plus and one will be minus. Now we're going to use that zero product property, which tells us to take your first piece, that entire thing, set it equal to 0. Take your second piece, that entire thing, and set it equal to 0. Use your inverse operations. Now notice that these are going to require an extra step, because not only will we do our -3, but now notice we still have that x with the 2. So we're going to have to divide by 2. I've run out of room, so I'll just squeeze it over here. That's going to give us x equals -3/2. When I solve the other one, well, guess what? The only thing that actually changes as I solve this is that now it's a +3 instead of a -3. So I'll have 2x equals 3, and then when I divide by that 2, I'll actually get the same answer I got before, except it'll be positive. So my two answers are a -3/2 and a +3/2. And I'll just write that a little bit bigger up here so everybody can see that in my braces. It's -3/2 and a +3/2. Now, if you wrote that as decimals, you know I don't mind that. I love pretty decimals. But let's say that was reversed. Let's say it was a 2/3, which would be like 0.6 repeating. Ugh, don't write that down, okay? Then you just definitely would leave the fraction. But these look good to me. So here are two examples where it was already set equal to 0. Awesome. So we just had to move on to that second step where we had to factor. Let's see what the next example holds for us. All right, so this would be example number 5. All right, example number 5. Is it set equal to 0? Check. We just got to factor it. All right, notice that these, and actually the next one right next here too, have 3 terms. So that's where we talked about the X method. Again, guys, as I reiterated in my videos before when we were doing the factoring, if you watch those, guys, X method is really just a way to organize your information. But what you're doing to solve or to get these factors is really just knowing what should you multiply to be and what should you add to be. So what we notice is that technically this is just a 1 in front. This is the A value of the quadratic. This -12 is the B, and this 32 is the C. So the first thing you want to do is go ahead and multiply the A and the C. So that would give us 32. And what Edgenuity was doing was just organizing that in an X. They were saying, well, let's put that AC value up top here, and whatever the B value we'll put in the middle there. So 1 times 32 gave us the 32, so that's what would go up top here. The B value was a -12, so that would go right here. And what this X is doing is just reminding you of what you have to do to find your size. You need to find the 2 numbers that will multiply to be 32, but then at the same time they have to combine to be -12. So I'm looking for 2 numbers, and I'll just clarify it over here, that multiply to be 32, but come together to be -12. Well, the first thing you might notice is that if you need the product, meaning the answer to the multiplication, to be a positive number, but yet you need them to combine to be a negative, well, the only way for that to happen is to make sure that both of these numbers are negative. Because we know that a negative times a negative is a positive, and if I take a negative and add more negatives to it, I'll still keep my negatives. Use your calculator if you'd like, but the 2 numbers that will work here will be a -4 and a -8. So -4, -8. So this x is, again, just a way to organize that information. Over here, I'm just showing you why those are the two numbers that work, because -4 times -8 multiply to give you 32, and -4 plus -8 will give you -12. So continuing with that same kind of x method, what they'll tell you is now let's take the original polynomial, that x squared, but instead of writing -12x here, we're going to write -4x and -8x. And those 4 and 8, those numbers just came from right up top there. And then we write the plus 32. So this right here is just the original problem rewritten to have the middle term broken up. Now we're going to use that double grouping. We're going to look at this first half right here, and we're going to pull out the GCF. The GCF between those two would be an x. It's what they have in common. And if you divided out that x, that would give us an x minus 4. So basically what we've done here in blue is we figured out what should go in here so that if you distributed it back, it would give you the x squared minus 4x. Now notice over here for this half, you have a minus sign in the middle there. Whatever sign is in the middle here has to be the sign that gets pulled out from that second half. So when you look at this second half, only the 8 has the x, so we're not going to be able to pull out an 8. But we also notice that between 8 and 32, they can both be divided by 8. Remember, the goal is to divide out to pull out the greatest common factor, the biggest thing possible. And then because of this minus sign, what we're going to end up doing is pulling out a minus 8. Well, what that's going to mean is that dividing by that -8 will leave us with just an x here, but then that minus 4 right over there. Because again, just to clarify, guys, you're taking this -8 and you're dividing it into both pieces. So the positive 32 divided by the -8 will give you the -4. And why that's so important is because with this method of factoring, our last step here is to pull out that common binomial. That is now like your GCF. And that common binomial is going to go ahead and be the first part of your answer. And then these kind of pieces that are on the outside here, we're just going to throw those right next to each other as the second part of your answer. So to factor that quadratic trinomial up top, we should get x minus 4 and x minus 8. Again, that thing is still all equal to 0, and we still have more work to do. So the most important thing to remember about this first section is that it really is no different from the last unit you just did. However, you've got these extra steps here where now you have to solve. So we're going to take the first piece, x minus 4, and we'll set that equal to 0. Add 4 to both sides. That will give us x equals 4. Over here, we'll have the x minus 8 equals 0. To get the x alone, we will add 8. And now that will give us 8. So our two answers are positive 4 and positive 8. And again, number 6, reviewing factoring again. It's already set equal to 0, so we're good to go with that. However, we will need to now do our factoring process. So we're going to go ahead and review that x method again. Again, here's our a, our b, and our c. And here's our x. We want to go ahead and take a times c, and that will give us -10. That'll go up top. The b value will go down the bottom. And again, just to clarify what needs to happen here, we're looking for the two numbers that multiply to give you that AC value, the guy at the top, but two numbers that will then combine or add together to give us the 3. Now, if you remember from our factoring, this gets a little tricky because if we want two numbers to multiply to be a negative product, we know that one of them has to be negative. So we said, well, as we go through and look at our factors of 10, let's not so much think about what's going to add to be the 3, but subtract. And then we can mess around with the signs. So if we want to get a negative 10, well, let's think about the factors of 10, meaning numbers that multiply to give us 10. That would be 1 and 10, 2 and 5. Now, knowing that one of them will have to be negative, and when we do a negative number plus a positive, we're really just subtracting. That's why we're looking now for the factors that will subtract and give us 3. Well, 10 and 1, well, that'll give us a 9. So that's not going to work. But here, 5 minus 2 is 3. So there we go. Now we just have to make sure we've got our signs set up properly. So we want to make sure that when we put these together, one being positive, one being negative, we get a positive 3. Well, the only way to do that is to make sure that the bigger number has that positive sign. So our two values will be the positive 5 and the negative 2. And let's just see it in the little statements just to confirm. 5 times negative 2 is definitely negative 10. 5 plus negative 2, there's your positive 3. So those will be our two numbers we use. And therefore, when we write this quadratic again, breaking up that middle term, this 5 and negative 2 will be the coefficients of our x terms. So it'll be 5x minus 2x and then minus 5. So again, just to review, we're writing the exact same first and second term. The only thing that has changed is the 3x has now been broken up into 5x minus 2. And now let's do our double grouping. Hopefully this serves as a review for you guys. Okay, we won't go through the others in as much detail, okay? So if you are having trouble with the factoring, please remember that you can always go back to the Unit 10 videos to refresh your memory. So we'll take out the GCF of these two here. Well, that's just gonna be an X, because the 2 and the 5 don't have any other common factor. So we'll pull out the X, which will leave us with 2x plus 5. Over here, again, that first guy is negative, so I know I'm gonna pull out a negative, but now as I'm looking at a 2x and 5, it doesn't even really have anything. So it looks like the only thing I'm gonna be able to pull out is a negative 1. Well, when I do that, I'll still get that 2x plus 5, so I'm good to go. Maybe looking at this, if I thought about this a little bit more, maybe just to make the math a little bit more easily able to be kind of factored, maybe I would have maybe switched these, which would give me the same answer as well, but that would kind of give me the 2x I could pull out here and the 5 over here. But regardless of which order you write them, you should still get the same binomials when you see your final factoring answer. So even if you switch them, one of your binomials will still be 2x plus 5, and one will still be x minus 1. And of course, don't forget that the point of this was not just to factor, but to actually also solve it as well. So now we'll go ahead and take this guy, set him equal to 0, and we got this guy, set him equal to 0. So the whole point is to make sure that we can factor so that now we can take the pieces, set them equal to 0. 2x plus 5 equals 0. We'll have to subtract the 5 to slowly get that x alone. Of course, it's not going to be alone just yet because it still has that 2 there. So then we'll go ahead and divide by 2, and that will give us negative 5 halves, which will also be negative 2.5. Over here, we'll add 1 to both sides, and that will give us x equals 1. I apologize for taking up too much room there. So our final answer is here for number 6. Right here, the negative 5 over 2, or negative 2.5, and positive 1. And just to clarify what these answers mean, it's just like solving any equation. you take your answers, and if you want to, you could plug it back in and make sure it checks out. So if you got the -5/2 and you're like, wait a minute, that seems weird. Why do I keep getting fractions? All right, take that -5/2 or -2.5, same difference, plug it in for x. Square it, times it by 2, add it to 3 times the -2.5, and then lastly subtract by 5, and you should get 0. So these solutions basically are just telling you what would x have to be to have this all zero out. Now, just like the other two that we started with, these were already set equal to 0. So you were golden. You could just start your factoring. Unfortunately, down here for 7 and 8, notice that they're not already set equal to 0. Instead, we've got a 20 on this side. Instead, over here, we've got a -10. That's not going to work. So what we're going to have to do here is make sure we set it equal to 0 by moving everything to the same side. So for number 7, guys, notice you've already got your x squared and -8x over here. So, you know, this is the guy that needs to move, okay? No sense moving 2 people to the right when here it can be accomplished with just moving 1 person to the left. He is technically a +20, so remember to move him, we'll have to make him a -20. Now when you move him, and this was important to remember the whole year we were kind of working on this, it's okay if you move some to the other side and he doesn't combine with anybody. That's okay. He's not like terms with an x squared. He's not like terms with a -8x. All right, let's just make sure we write them in that order to make sure they're standard form and be done with it. Remember, the x squared goes first, then the x term, and then the constant. All right, let's go ahead and now do our factoring. All right, number 7 is much like number 5. There's just a 1 in front of here. So again, a times c is really just giving you that last number there of -20. And then we have a -8 for our b. So just to clarify, we're looking for 2 numbers that will multiply to be -20, but yet add to be -8. So again, they multiply to be -20, and they're going to combine to give you -8. Because the 20 is negative, we know that we're looking for 1 positive and 1 negative. So as you go through and think about all those possible factors of 20, don't necessarily think about adding so much right away, but subtracting. So if I think of 20, I might think 4 and 5 right away. But if I make one of them positive, one of them negative, therefore having to subtract them, that's just going to give me a 1. So go through until you find the factors that would subtract to give you an 8. And that's going to be 2 and 10. Now, of course, we want the -20. So now we've got to mess around and say, well, who should be the -1 to make sure I end up with a -8 when I add them? Well, if we want a -8 at the end, then the bigger of the 2 numbers must also be negative. So it's going to end up being a +2 and a -10 that work. Now to save us some time, guys, honestly, I'm not going to go through all this work like we did for number 5. If anybody's watched the videos from Unit 10, you already know this shortcut. For those of you who don't, I'm going to share it with you now. There is no reason to go through and do all this work when you have the a value of 1. If you think about what we did up here for number 5, guys, we did all that work to find that the 2 numbers were going to be -4 and -8, and then when I factored, it was -4 and -8. Well, this same thing will happen here. Because this quadratic just has a 1 here, these numbers I find here in blue, they're the numbers that are going to go with my x's in my final answer. Well, and when I say answer, I mean my final factoring, because again, this whole thing is technically set equal to 0, so I still have to actually split them and solve them. But that's going to be a good shortcut for you, especially now that factoring is only one part of the step. And we don't want to waste our time worrying so much about the factoring when we've got this extra step now down here. So once again, guys, only if this A value is 1, we can use this shortcut. Find your two numbers and just slap them right in there. And then solve. So we've got x plus 2 equals 0. Minus 2, that's going to give us negative 2 for our answer. And then over here, we've got x minus 10 equals 0. In this case, add 10, and we're going to get positive 10. So our two answers are negative 2 and positive 10 for number 7. For number 8, again, not set equal to 0, so we're going to go ahead and have to move that over first. So we're going to take that negative 10. Because it's negative, that means we've got to add it when we move it over. I notice that on this left side here, I actually have another constant right here, that negative 2. So you notice that there is something on the left that will match what you're moving over. Yeah, just write that guy that you moved over right underneath them, because that way it'll be just more of a visual of what math needs to be done. So when we move that over, it did not affect the 3x squared. He's still the way he is. It will not affect the positive 10x, but what it does do is it changes that negative 2 into a positive 8, because negative 2 plus 10 is a positive 8. Now, note here, guys, that unlike number 7, this A value is not 1. So unfortunately, we're not going to be able to use this shortcut, okay? Instead, it's a 3, so now I've got to go through and do all my work. I got to take that A value, I got to times it to that C value. When I multiply those together, that's going to give me a 24. So the 24 is the top guy in my X. This middle guy here, that's the B value. He's going to be the bottom of my X. So now I'm looking for two numbers that are going to multiply to be the 24, but yet add to be 10. Because both of these are positive, all we got to think about are positive numbers. So think about two numbers that multiply to be 24 and then add together to be 10, and that will be 6 and 4. So now when I break this up, again, no shortcut, guys. Your answer is not 6 and 4, I promise you. We got 3x squared, break up that middle term into plus 6x plus 4x, and then of course the 8 right here. And don't forget, it is technically equal to 0. Okay, so number one thing, guys, just remember that once you move that term from the one side over to the other, getting it to 0 out, remember that this is our new problem. Okay, so this is the same thing that gets written down here, except we've split up the 10x into 6x and 4x. Now we'll do our double grouping, so taking out the GCF of this first side here. Well, what they both have in common that can divide evenly into them is definitely a 3 and then an x. So that 3x comes out in front. When we divide it out, that'll just give us a 1x here, or just an x, and then plus 2. Over here, a 4 is the greatest common factor, because a 4 divides evenly into both those numbers, and it is the biggest number that does that. And that will give us x plus 2 again. The common piece here, the x plus 2, becomes half of our answer with the factoring. The guys in the front will become the second set of parentheses. So this is the actual factored version of our problem. And now we just have to go ahead and solve those. Let's just add in some little extension here. So we've got x plus 2 equals 0. Ooh, that did not work. Eesh. So that will give us x equals -2. Over here, we'll have 3x plus 4 equals 0. We'll subtract the 4 over to the other side. That will give us 3x equals -4. Divide by 3, and that will give us x equals -4/3. Okay, so our answer down here, we will have a -2 and a -4/3. That's pretty much as crazy as it'll get. That you'll have to do some moving around, but then you'll have an a value that's not 1, it'll be another number. So therefore, after doing your x, your organization of your numbers, you will have to continue on with the double grouping. And we've just got 2 more for you. And these are just going to be a little bit crazier where you will have to go ahead and move around. But again, all of this really is, if you think about it, guys, has been one big review of graphing, right? Or I'm sorry, graphing, of factoring, okay? So number 9, notice that I've got x squares on both sides. I also have 2 terms on both sides. So technically, which side you want to move everything over to would be really up to you. But I always think about my x squared first. And I think, well, how can I move my x squares so that they stay positive? So with that being said, that means that it'd be much easier to just move that -x squared. Because therefore, he will become positive x squared. And when I add it over here, that'll give me a 4x squared. And so now it's nice and positive, which is always beneficial. Now I'm just going to rewrite the rest of the problem as it stands, just so we can kind of wrap our mind around what it looks like. So far we combined the x squares, and we're at 4x squared minus 7x equals 2. At this point, we still have one more thing to move over, and that's going to be this 2. Now this 2 is technically positive, so to move him over, we'll have to subtract him. Now notice that he does not have a friend. He does not have something that is his like term over on the left side, and that's okay. We will just simply write the pieces that we all have along with that -2 in standard form. So once again, remember that standard form means that you've got your 3 pieces, you've got your x squared term first, then your x, and then your number. And so this is the quadratic that we will now be factoring. So starting with our x, remember up top here, we take the a times the c value. So that'll be 4 times -2, which is -8. Our b value right here, which is a -7, and that will go on the bottom. So again, just to make sure that we're all clear with kind of the math that needs to be done, we're looking for 2 numbers that multiply to be -8, but those 2 numbers also must add or combine to be -7. Because this product, that 8, is negative, we know that one of our numbers will be positive and one will be negative. Well, then when we go to add a positive and a negative, well, that's really just subtracting. So in our mind right now, we want to think, well, what 2 numbers multiply to give us an 8, but subtract to give us a 7? So that's going to be 8 and 1. Of course, now we've got to kind of mess around with our signs to make sure we've got them correct. Because we can't just leave it as +8 and +1, because that's not going to give us that -8 product. I do know that when I combine these, I want the 7 to be negative. Well, remember that the answer to a problem where you're adding a positive negative always has to match the sign of the bigger number. So that's going to tell us that the -8 is the one that we need in order to get that -8 product and that -7 for the combination. So that gives us a -8 and a +1. Now again, unlike that one that I showed you the shortcut to, this x squared has a 4 in front. So you can't use 8 and 1 down there in your sets of parentheses and be done. You've got to do the full out factoring. So you've got the 4x squared. Then we'll take the two numbers we found here and put x's on them. And then we've got the minus 2. So we're rewriting the problem that we found there, but instead of using minus 7x, we're using, we're using a minus 8x and a positive 1x. It's positive 1, so make sure that's a plus sign. We're going to go ahead and do our double grouping. So therefore, we're going to pull out that GCF of both halves. So the GCF of this first half is a 4x. When I divide out a 4x from both of these, I get an x minus 2. In the second half though, notice I just have a 1 and a 2. Well, that's not going to give me anything. And this guy has an x, but this guy doesn't. Well, remember what we said with this double grouping, even if it's just a 1, we will have to take it out so we get the proper look. So because this is a plus, we're going to put a plus 1 here, and that will be x minus 2. So in this case, notice that we do have that common binomial. It's the x minus 2. So let's go ahead and throw that down as part of our answer. And then we'll go ahead and take these things that are in the front, put them together, and that'll be our second binomial. With all that being said, we are not done yet. This was just the part that we needed to do to get it set equal to 0 and to be factored. Now we're right back to our first two problems that we had started with. We've got two binomials being multiplied, and it equals 0. So either this guy is the 0 one or this guy. Hopefully we're getting pretty good with these tiny ones. If it's just an x and a number, your answer is just the opposite of that guy. So we've got an x equals 2. Over here, we are going to have to do a little bit more math. We're going to have 4x equals negative 1. Divide by 4. X equals negative 1/4. So our two answers are solution, negative 1/4, comma 2. That was definitely a long one, okay? I lied before. This is the hardest it would get, okay? But remember, guys, the idea with the videos is that you can pause, you can rewind, you can text me, you can message me, let me know what questions you have, okay? So this was number 9 in its entirety. Whew, that's a doozy. All right, hopefully number 10 won't be so bad. And I'm gonna tell you the truth, it's not. All right, last but not least. Okay, notice though, unlike number 9, guys, we do only have one x squared term, so that's cool. Except notice that it's over on the right and it's a negative. Now it's okay if your terms all go to the right. I don't care just as long as everything's set equal to 0. But notice that it's a negative x squared. I'm just gonna tell you guys, we weren't able to be in school to talk too much about this, but it is so awkward factoring something that has an a value of negative. It just makes it so much harder. So let's go ahead and before we do anything else with any of the other terms, let's take that negative x squared and let's go ahead and add it to the other side. Now, of course, when I say to add it, we're not actually adding it to anybody because nobody on that left side is a like term with x squared. That's okay. We'll just go ahead and throw it in the front there. And then everybody else, the plus 10x, the plus 9 stays the way it is. And of course, we still have that negative 6 on the end there. All right, at this point, last thing to do now is to take that negative 6 and add it to the other side. Notice that it does have a like term. It is like terms with the 9. Oh, that should be a 19. Goodness. Hopefully, if we were in class, somebody would have raised their hand and said, I don't get that. Okay, so that's a 19. All right, there we go. So we got x squared plus 10x plus 25 equals 0. There we go. All right, so the good news with this problem is now not only do we make the x squared positive, but it is a quadratic where the a value, the coefficient of the x squared, is just 1. So if that's the case, then we can use that shortcut we talked about. We still have to answer this riddle up here. We still have to say, all right, what's going to multiply to be 25 and add to be 10? So we'll still have to do the riddle. Again, just to clarify, we're looking for two things that multiply to be 25 but add to be 10. And hopefully by now you guys have all figured out it is 5 and 5. But now again, because the a value is just a 1, we can use the shortcut, which makes us happy. So I'm going to draw a little smiley face. The shortcut tells us that all we need to do is to go ahead and slap down our parentheses, first term being x, and then those two numbers we found, we can just go ahead and put them in. So when we factor this, this will end up being x plus 5 times x plus 5. Don't forget it's set equal to 0, so we still got one more step. We gotta go ahead and solve them. Well, here we've got x plus 5 equals 0. Over here we've got x plus 5 equals 0. So for the left one, I subtract by 5 on both sides. X equals negative 5. For the right one, minus 5. I'm getting the same exact thing. All right, remember what I said, guys, in the beginning. Because these are called quadratics, meaning you've got that x with a square, you're going to have two answers. But what might happen here is they might be the same one. That's what we call a double root. When your solution just shows up twice. So this is called a double root. So we really just need to say 5, negative 5. If I'm doing the braces, I would just write negative 5. Okay? And you'll learn in Algebra 2 what this would look like graphically, that your graph is going to come down, it's going to hit at negative 5 and like bounce away. But right now, all I want you to know is that sometimes you may get the same answer, and that's okay. That is what we call a double root. All right, sorry for the long notes. I just wanted to make sure you had a lot of different examples for the homework assignment that you will now be doing. It is on a Google form, okay? So look on Google Classroom, fill out the form. There are 10 questions, and then we'll give you feedback right away, whether you're correct, whether you're wrong, and different guidelines on if you were incorrect, what you should have thought about, okay? So as you go through that homework and get your answers, I would go ahead and jot down any comments that I've provided for you on that as well, just to make sure you've got as much material as possible, so that when it comes time for the quiz, which is technically open notes, you got everything you need, okay? Again, if you have any questions, make sure you email me, make sure you message me, make sure you text me. At this point, you should have all possible forms of communication out there that you can reach me, okay? Good luck and enjoy.